Mainframes. They're pretty much the bedrock of the global economy, right? They process everything from your credit card swipes to your flight reservations. But when a system is that critical, how in the world do you keep tabs on everything that's happening inside it? It feels like a black box to most of us, but today, we're going to find the key. I mean, let's just pause on that question for a second. This isn't about some server sitting in a rack somewhere. We're talking about the system of record for the world's biggest banks, insurers, and airlines. The sheer scale it's just mind-boggling. And when we say everything, we really mean everything. You gotta know which program is eating up the most processing power, who's touching sensitive data, every single login attempt, whether it worked or not, and all the data that's flying in and out. It's a staggering amount of information to capture. So the answer to that huge challenge is something called SMF, or System Management Facilities. And honestly, the best way to think about it is as the system's official black box recorder. Just like on an airplane, if something goes down on the mainframe, you can be sure that SMF has a record of it.
Okay, so what kind of information is actually packed inside this black box? Let's peel back the cover and take a look at the incredible scope of the data it collects.
And the scope is wow. SMF isn't just one giant log file. Nope. It's this highly structured system with over 219 different distinct record types. Each one is tailor-made to capture a specific kind of activity, everything from hardware performance to application behavior. And it doesn't just cover IBM stuff. Tons of other software vendors write their own SMF records too. These record types are all grouped by what they do, which gives different teams exactly what they need. So, for example, Type 30, that's the gold standard for financial chargeback. It tells you precisely which job used which resources. Type 70 through 79 are where the performance tuners live and breathe. And Type 80, well, that's the security team's best friend, creating this ironclad audit trail of every sensitive access attempt. The list just goes on, covering databases, network traffic, you name it. Right, so the crucial point here is that this incredible data collection system wasn't just built by accident. It was actually designed from day one to accomplish 4 absolutely essential missions for any company running a mainframe. First up, capacity planning. You can't just cross your fingers and guess when you'll need to upgrade your hardware. SMF gives you the hard data, showing you how resources are being used over time. This lets engineers predict what they'll need down the road and justify those big investments before the system ever slows down. Next, you've got performance tuning. You know, if capacity planning is about building more lanes for the highway, tuning is about finding that one slow car that's clogging everything up. SMF data lets engineers zero in on the exact application, or the specific database query, or the subsystem that's causing a bottleneck so they can get it fixed. Then there's something that's absolutely vital for the business side of the house: cost accounting. Look, a mainframe is a shared resource, and it's an expensive one. SMF meticulously tracks which department or app is using what percentage of the CPU, so those costs can be split up fairly. It basically turns IT from this mysterious cost center into a totally transparent service provider. And holding it all together is security and auditing. In today's world, with all the regulations and constant threats, this is just non-negotiable. SMF provides this unchangeable audit trail of who accessed what, when they did it, and from where. For security analysts and auditors, this data isn't just nice to have, it's priceless. Okay, so that's the theory, but how does this all actually work in the real world? Let's put on our detective hats and look at 3 common mysteries that system admins face every single day, and see how SMF gives them the clues to crack the case. First up, a classic question you'd get from the finance department. The monthly IT bill just landed, and they want to know who's driving up the costs. The answer is waiting right there in the SMF Type 30 records. You pull a simple report, and it's crystal clear. The payroll 1 job, which belongs to the finance department, ate up over 12,000 CPU seconds. Boom, mystery solved. No guesswork, no arguments, just pure data. All right, next mystery. A performance analyst notices costs are slowly creeping up, and some jobs seem a little sluggish. The overall system doesn't look that busy, so what in the world is going on? So we dive into the SMF Type 70 data, the system performance records, and there's our culprit. The main processors, they're just fine, humming along at 52%. But the specialty engines, the ZIPs, which are designed to handle certain workloads more cheaply, are at 98%. They are totally saturated.
That means work that should be running on those cheap engines is spilling over onto the more expensive general processors. And that's what's driving up costs and creating this hidden bottleneck.
And for our final mystery, a security alert just popped. Someone just tried to access the master payroll file without authorization. The security team needs answers, and they need them, like, right now.
And SMF delivers the smoking gun. The Type 80 record from the security system gives you this beautiful, clear log entry. User, John Doe. Action, failed attempt. The exact file name. The reason? Not authorized. And the precise time, 22:45. I mean, that is the kind of actionable intelligence that makes security investigations quick and definitive. Case closed. Now look, SMF technology has been around for decades, so it's a fair question to ask if it's even still relevant. The answer is a huge, resounding yes, but the way we use its data has completely changed. The evolution here is just night and day. In the past, you'd run these complex batch jobs overnight just to sift through the SMF data. Today, that exact same rich, granular information is streamed in real time into modern platforms like Splunk at Elastic. Teams can now build live dashboards and set up instant alerts, turning what was once historical data from a black box into the live, beating pulse of the entire system. So, to wrap it all up, SMF is kind of like the root system from which the mainframe's strength really grows. It's the definitive master telemetry system, and it provides a level of transparency and accountability that's just unparalleled anywhere else. This is the foundation for the platform's legendary efficiency and auditability. It's so fundamental, it even drives IBM's own software pricing models. It's truly a first-class citizen in the modern world of data. And that kind of leaves us with one final thought. The mainframe has had this kind of power for decades. So think about the systems that you work with every single day. If you had a complete black box recorder that captured everything with this level of incredible detail, what mysteries would you be able to solve?